Hello and welcome to Multiparadigm Data Science with the Wolfram Language. Section 2, Getting Your Data into Shape. In this section, we will look at functionality needed for the wrangle stage of the workflow. Data wrangling involves importing raw data and converting it into a suitable shape for ease of use during rest of the analysis. A multi-paradigm workflow has to be able to handle data in different formats from different sources, reshape the data into different structures, deal with messy data, extract useful features from it, and if needed, reduce dimensionality of high-dimensional data. And while dealing with all of this, the goal is to write code for a set of automated tools for the data wrangling process so that it is much easier to go through this stage next time the workflow is used. Let's look at some examples of importing real-world data from different sources. In best case scenarios, high-quality curated data may be available from repositories. For data that has been curated properly, there really is no need for much wrangling. For example, the Wolfram Data repository, which is a publicly available resource for computable datasets, it has curated and structured data available for immediate use. We can browse the site for datasets by category or by type. The data is all clean and ready for computation. So if we find a dataset that we'd like to use, we can just load it into our system and start working with it. In addition to the data repository, the Wolfram language has an extensive built-in knowledge base that can be explored for interesting data, or it can also be leveraged to augment some existing in-house data with additional information. To access this knowledge base, we can simply type in words in English, which are then interpreted into canonical entities representing real-world objects. We can access the various properties of these entities and use them for computation. There are millions of entities across hundreds of entity types built into the Wolfram language. Also, there are collections of domain-specific datasets like geographic data, engineering and medical data, social, cultural, and linguistic data. So that's curated data, but most people want to import their own data into the system. And we can do that with a simple import statement for files residing either locally on the computer or online on the web. To support a multi-paradigm workflow, the Wolfram language can handle a wide variety of formats. The import function automatically deals with the format of the file when importing data from it. Sometimes it is useful to save data and intermediate results in the middle of the workflow. Data can be saved as Wolfram language expressions using save or dump save, and then read back in again using get. Okay, now let's move on to databases. In many projects, data is available in a relational database, so the multi-paradigm workflow must be able to connect to the database and get the data from it. Here's an example of opening a connection to a database, looking at the tables in it, and fetching data from a table using a Wolfram language function. Alternately, we can use standard SQL to fetch the data and work with it. It is also possible to represent a relational database symbolically in the Wolfram language by constructing an entity store. This allows the relational data from the database to be structured as entities, very much like the built-in entities in the Wolfram data framework. So now we can use the same syntax to query and use the properties of these entities for computation. Moving on to the World Wide Web, which is another major source of data. There are multiple different ways of getting data from the web. Many online services provide APIs which can be used to import the data from these services. Here's an example of connecting to the Twitter API and downloading tweets made by a specific Twitter handle. Or we can simply search the web for generic content, or maybe specify the type of content we'd like to search for. Wikipedia is another great resource, and it can be searched not only for text, but other metadata as well. Finally, if we are just given a URL, we can simply scrape the data off the web page. Depending on the requirements of the project, we may have to scrape everything available on the web page and then parse the raw data to make sense of it. Or we can scrape specific elements like images or hyperlinks from the page. So that covers a number of different data sources that we can work with when we are trying to wrangle data. Now, some of us may already have some in-house data that we'd like to analyze as we follow the project workflow in this course. But for those who are looking for interesting data sets to work with, here are some publicly available resources to get started. We've already looked at the Wolfram Data Repository. The US government's Open Data website is another great resource, so is NASA's Open Data Portal, UCI's Machine Learning Repository, the Kaggle contest, the 538 block collections, and so on. In summary, in this segment, we looked at importing data from different sources, loading it into the system for exploration and analysis. We looked at getting curated data from the Wolfram Data Repository and built-in Wolfram Knowledge Base, and we also looked at simply importing data from files in a variety of formats residing either locally or online on the web. We looked at connecting to APIs to download data from online services. And last but not the least, we looked at scraping data elements off web pages. We hope you'll be able to use one or more of these options in the wrangling stage of your project. In the next segment, we will look at restructuring data to make it ready for use in various stages further downstream in the workflow.